Last episode, we put the D016's video quality through the ringer. Today, we're going under the hood. And let me tell you, this episode is packed with surprises and a few plot twists. Now, take a good look at it while it's still in one piece, because in just a few minutes, it's going to look like this. Does it look like a crime scene? Maybe, but to get to the truth, we have to perform surgery. Wow, just looking at the exterior, the seams are incredibly tight. It's built like a little fortress. Looks like my mission today isn't going to be easy. First step, let's get this bracket off. Let's start by removing the top screws to see if there's an opening. I doubt it, but let's start here anyway. Yeah, looks like there's no way in from this side. It looks like the screen is our only way in. I have to say, this screen is seriously difficult to remove. It's so flush. Let's strip these smaller components and see if they hide a secret entrance. All right, fine. It looks like we're back to the screen. One final forceful pry. Open. As I suspected, if you want to see the heart of this machine, you must go through the screen. That was a serious workout. Let's get the screen fully detached, clear away these last little edges, and see what all the fuss is about. This is a 3-inch screen. It's pretty good. Pop out these 4 screws, remove the panel. Oh, so that's where my pry tool ended up. Welcome home. Here's the motherboard. Next, let's pop it out. Glue dispensing is applied here. It is designed for a more reliable connection. We've got some Kapton tape here for insulation. It's heat resistant and keeps the circuitry protected. Let's peel it back. They've used a dispensing process here as well. Once the connecting bits are cleared out, the main board comes right out. This right here is the GPS cable. Good build quality. Let's take a look at the main board. Right off the bat, we've got this massive shield here. Buttons on the side, the SD card slot, and the FFC ribbon cable. Turning it over, there's a tiny thermal pad on the back. Now, let's get this thing torn down. Like the M550, the D016 uses an FFC cable. Think of FFC as a standard off-the-shelf extension cord, while FPC is a custom-tailored circuit. It's a pragmatic choice to keep the price friendly. Prying off the shield, we can see the thermal paste applied to both sides. They did include it for cooling, but the coverage is very lean, just enough to meet the baseline. Now, let's look at this beautiful green board. This is where the real story begins. The commander-in-chief here is the Allwinner V851S3. This chip uses SiP tech, hugging the RAM inside so the board stays super clean and budget-friendly. Instead of chasing raw resolution, it's flexing a 1.0 TOP SNPU, meaning it's an absolute AI nerd, handling ADIS like lane warnings, like a breeze. The catch? It favors brain over brawn. For 4K, it leans on software sharpening algorithms rather than raw sensor muscle. So, while its AI is brilliant, pure 4K clarity isn't quite at that high-end Novatech level. Forcing native 4K through it is like asking a cute hatchback to tow a heavy trailer. It works, but it's sweating. It's happiest at 2.5K. Which perfectly explains why our last test showed exactly a 2K resolution. Next to the CPU, we see the Ethernet chip. This is a highlight. By using this chip, the D016 can receive high-def video from the rear camera with almost zero latency and way more stability than traditional analog cables. We also see the Boya Micro flash chip handling the firmware. It's a very mature setup, but when you run that NPU at full load for AI features and record high-res video at the same time, this chip is going to get hot. If the cooling isn't perfect, the chip might throttle in the summer heat. And this is exactly what led to the missing frames we experienced in our last video. Finally, the ATBM6162. It's a 2.4 GHz single-band Wi-Fi module. It's reliable and cost-effective, common in smart home tech. But let's be real, downloading a massive 4K file over 2.4 GHz is going to take a bit of patience. Naturally, I flipped the board over, hoping to find some extra cooling defense. Prying open the back shield, well, it's just conductive foam to handle static electricity. Not a single drop of thermal paste here. It turns out this side is purely a shield with no functional components. So the front side is completely on its own when fighting the summer heat. And that covers the main board teardown. To summarize this little green board, the PCB layout is super clean. The SiP packaging is a clever touch. And adding that Ethernet chip proves they really care about data stability. Even though they had to make some tactical compromises on the Wi-Fi speed and RAM capacity, it's still a highly capable, budget-friendly visual solution. Next up, we have this heatsink. And the material here is pretty wild. Listen to the sound when I tap it. I also noticed you can actually write with it. Feels a lot like a pencil, right? This is a carbon-based composite heatsink. It's super rigid and lightweight, which does a great job keeping the overall weight of the dashcam down. But here's the science part. Mass-produced carbon composites like this generally don't conduct heat as efficiently as traditional metals. While choosing this over solid aluminum shaves about 20% off the manufacturing cost, it does mean a slight trade-off in cooling efficiency. Now we reach the sensor. Wait, look at this. We're missing a screw here. Someone was definitely dreaming of their lunch break. Let's pull the sensor out and take a look. Oh, they've hidden the real model number of the sensor. I've tried searching for this specific ID, but there's zero public information available. Next, let's talk about the mount. The D016 comes with a suction cup mount. Now, I know a lot of users still love these because they're incredibly convenient. You can literally slap it on one car today, pull it off, and move it to another tomorrow. That's why suction cups used to rule the market. But notice how most major brands have quietly moved to 3M adhesive tapes over the last few years. It's become the modern industry standard for a reason. Suction cups are great for the honeymoon phase. But after a year or two under the blazing summer sun, the material inevitably degrades, loses its seal, and, well, gravity always wins. The dashcam just falls right off. 3M tape, on the other hand, is a lifetime commitment. It's less convenient if you swap cars every week, but it's absolutely the gold standard for long-term reliability. So it's a classic trade-off between temporary convenience and long-term peace of mind. Let's tear down the bracket itself to check out the GPS module. Here it is. Now, there are no obvious model markings printed on the shell. I pulled a few strings and found out they're using the CBEST 1661 GGPS module. Not bad at all. But looking closer at the board, they've opted to omit a supercapacitor. Specifically, it's missing a core chip supercapacitor, a specialized component usually sourced from South Korea. Omitting this shaves off a bit of manufacturing cost. The trade-off here is all about positioning speed. Without that capacitor, you sacrifice hot start times. A hot start with a capacitor keeps the satellite data active, making your next lock nearly instant. Without it, the camera has to do a cold start almost every time, which can take up to 30 seconds instead of just a few. Another classic compromise for a sharper price point. And finally, let's unclip this last little bit right here. This is what feeds power to the entire GPS module. And just like that, the teardown is complete. So what's the final verdict on the D016? After seeing every internal component, it's clear that this device is a very clever exercise in balancing performance and cost. It's not trying to compete with ultra-premium, expensive native 4K flagships. And that's completely fine. Instead, the engineers focused on what truly matters for day-to-day driving: reliable, lag-free recording thanks to the high-def Ethernet link, and smart ADS features powered by that efficient NPU. To keep the price accessible for everyone, they made some practical, tactical design choices on the Wi-Fi band, the GPS capacitor, and opted for a lightweight carbon composite heatsink. If you're looking for a highly capable, budget-friendly smart helper that secures the essentials and offers great data stability, the D016 is a very solid, pragmatic choice in its class. That wraps up our full teardown of the D016. What do you think about these engineering choices? Let me know in the comments below. If you enjoyed this deep dive, please drop a like and subscribe for more pure tech breakdowns. Thanks for watching, and I'll see you in the next one. Take care.